All right, let's jump straight into this explainer and tackle how commercial buildings solve their absolute biggest, most invisible comfort problem: high humidity. You've definitely been there, right? You walk into a space that feels uncomfortably clammy, even though the AC is absolutely blasting. Well, today we're diving into the fascinating mechanical life hack engineers use to fix this exact issue. It's called hot gas reheat.
Here's our roadmap for today. We're going to cover the hidden humidity problem, the dehumidification dilemma, exactly how hot gas reheat works, why it's a smarter way to heat, and finally, how it protects both buildings and people. Let's get right into it.
Section 1. The hidden humidity problem, or dealing with moisture in HVAC. So most people just assume air conditioning is only about lowering the temperature. We look at a thermostat and think its only job is to cool us down. But in reality, modern HVAC systems are constantly fighting a massive, invisible battle against moisture.
To see why this matters, just picture a high-occupancy space: indoor pools, gymnasiums, aerobic studios, locker rooms, crowded schools, or even your local supermarket. In these environments, cooling the room is only half the battle. Massive amounts of moisture are constantly flooding in. Think about evaporation off a pool, perspiration from a tough workout, or even just outdoor ventilation air being pumped into a school auditorium. It is a continuous, heavy influx of water vapor.
Because of this, HVAC systems basically have to split their duties right down the middle. You've got sensible cooling, which is the one we're all familiar with, just dropping the physical temperature of the air. But then you have latent cooling, which is the actual physical removal of moisture. And in a lot of those buildings we just mentioned, that latent load literally becomes the dominant concern, completely taking priority over just cooling the room down.
Which brings us to Section 2, the dehumidification dilemma: removing moisture. This is a massive catch-22 in HVAC engineering. How do you wring water out of the air without freezing everyone inside the building?
The root of this dilemma actually starts with that little box on the wall. Standard thermostats only monitor temperature. They are totally blind to indoor moisture levels. Because of this, a space can quickly become cold and humid at the exact same time. The AC cools the room to the set temperature, clicks off, and completely ignores the fact that the air is still packed with thick, miserable humidity. To actually wring that water out of the air, the system has to work incredibly hard. The evaporator coil inside the rooftop unit has to get extremely cold, dropping the air passing over it to about 50 degrees Fahrenheit. The colder that coil gets, the more the warm, humid air condenses against it, allowing the system to literally squeeze the moisture out and drain it away.
So here's the million-dollar question. What exactly happens when a building desperately needs dehumidification, but it no longer needs sensible cooling? The space might already be perfectly cool, maybe even a little chilly, but it's still pumping full of moisture from an indoor pool. If the AC turns on and blasts 50-degree air into a room that's already cold just to remove moisture, the people inside are going to absolutely freeze.
Well, that brings us right to Section 3, how hot gas reheat works, bridging the gap. This is the elegant mechanical life hack that fixes everything.
Here's the brilliant cycle in action. First, the system intentionally overcools the air down to about 50 degrees to extract that stubborn moisture. But instead of blasting that freezing air right into the room, it intercepts it. The system redirects a portion of the hot refrigerant gas that normally leaves the compressor, sending it through a reheat coil just downstream. It takes that perfectly dry, freezing air and runs it right over that hot coil. And the result is basically magic. By warming that freezing 50-degree air back up to a super comfortable 65 degrees using its own waste heat, the system completely separates moisture removal from temperature control. You get perfectly dry air delivered back into the room without any of that bone-chilling overcooling. It completely breaks the catch-22.
Let's move on to Section 4, a smarter way to heat, focusing on energy efficiency.
Because you're probably thinking, wait a minute, aren't we just cooling air down to heat it right back up? Isn't that a huge waste of energy? Well, older or less sophisticated systems actually do cool the air to dehumidify it and then try to reheat it using electric resistance heaters. That means you're basically paying twice. You pay to run the AC, and then you consume massive amounts of raw electricity to create brand new heat. Hot gas reheat, though, it's beautifully efficient because it simply recycles heat that already exists in the system.
So instead of just dumping all that hot compressor heat outdoors into the atmosphere where it's totally wasted, hot gas reheat recycles it back inside to do useful work. Now, to be fair, it isn't entirely free. It does increase the compressor's runtime. But compared to the massive power draw of an electric heater, recycling that waste gas makes this a vastly more energy-efficient solution.
And that leads us to our final section, number 5, protecting buildings and people. Because beyond just saving energy and keeping us comfortable, this tech is absolutely vital for the physical survival of the building itself.
If you have a facility with an extreme latent load, like an indoor swimming pool, and you don't have aggressive dehumidification, the fallout is disastrous. Windows permanently fog up, metal ceiling and wall components aggressively corrode, mold spreads like wildfire, causing terrible odors and awful indoor air quality. Over time, the building materials literally just deteriorate and rot away.
To stop this kind of decay before it even starts, modern rooftop units act almost like automated shields. They don't just rely on that basic wall thermostat. They use a sophisticated arsenal of advanced humidity, dew point, and supplier sensors to constantly monitor the space. When humidity creeps up, the system automatically shifts into latent heat removal mode, perfectly balancing the hot gas reheat to stabilize the room before moisture can do any damage.
This really creates a profound shift in how we think about indoor comfort. Just look at this quote. "The building does not necessarily need colder air. What it truly needs is drier air." One of the biggest misconceptions in HVAC is that cold air automatically equals more comfortable. But honestly, it's the humidity that really dictates how we feel and whether our buildings survive.
So, the next time you walk into a packed supermarket or a gym and it feels icy and clammy, you'll know exactly what's missing: proper latent cooling and a hot gas reheat system. Knowing how intelligently this technology recycles waste heat, how much energy do you think standard buildings are wasting every single day trying to fight invisible moisture with the wrong kind of cooling? Hopefully, this explainer leaves you with a completely new perspective on the invisible engineering that keeps our everyday spaces safe and comfortable.